Yeah, so as Rachel says, I'm going to cover a little bit on the HRA process, and then I'll go into some detail on the various stages of the nutrient budget calculator and how it undertakes the calculation process. So just as a quick refresher overview of the HRA process, it's a three-stage process, or well, some people consider it a four-stage process, but I've wrapped up the derogations into one stage for the purposes of this presentation. So just to quickly summarize those steps, the first stage is the likely significant effect test, which is just a coarse filter really to identify, is there anything that we need to assess for this particular plan or project? And then the second stage is the appropriate assessment process, which is a detailed consideration of the proposal to ascertain whether or not it's likely to lead to an adverse effect on the integrity of the habitats site or European site. And then the third stage, if adverse effect cannot be ruled out, would be to apply the derogations. So I'll go through each stage in a little bit more detail. So as I say, when screening for likely significant effects, you're essentially determining whether or not there's the potential for the plan or project to have an impact on the European designated site. So it's really about checking whether there's anything that needs to be assessed. And I've highlighted there that mitigation can no longer be considered at this stage, which has been the case for some years now. So I don't think that's anything new to anyone. When thinking about nutrient neutrality specifically, the sort of considerations at likely significant effect stage would be, is the proposal going to generate additional wastewater? Is the proposal within the scope of the advice that you've received? So, for example, as we've discussed on previous calls, householder applications are likely to be outside of scope. So you could those sort of proposals could be screened out at likely significant effect stage and wouldn't need to go to further assessment. You also need to consider whether there's a potential impact pathway between the proposal and the designated site. So is the proposal within the catchment? Clearly, if it's not, then again, it can be screened out with regard to nutrient neutrality. And finally, highlighting that there are some specific criteria that Natural England have set out. At the moment, this is limited to the discharge to ground criteria for phosphorus, but I've made that a slightly more general statement because there may be other locally agreed criteria that are agreed over time that would enable developments to be screened out as not likely to have a significant effect and therefore not requiring an appropriate assessment. So where plans projects can't be screened out as not having a likely significant effect, the next stage is to go forward to undertake an appropriate assessment, which is essentially an assessment of whether or not there would actually be an adverse effect on the integrity of the European site as a result of the proposal. And that initially would be in the absence of avoidance or mitigation measures. You can then, obviously at appropriate assessment, consider the mitigation measures that are proposed to form a view as to whether, in light of those measures, there would still be an adverse effect. Again, highlighting that Natural England are a statutory consultee on all appropriate assessments. So Natural England have to be consulted on any appropriate assessment. So again, thinking specifically about nutrient neutrality, the purpose of the calculator is to provide the figure for the amount of impact that there's going to be. So it will provide you a figure for how much nutrient will be generated by the proposal, which then obviously gives you the figure for the mitigation requirement. So it provides you with that vital piece of information to use in the appropriate assessment. then the appropriate assessment would need to consider whether the proposed avoidance or mitigation measures are sufficient to offset that impact from the new development. And the sorts of things that you're going to have to be considering at this point are how certain that mitigation is. So is the measure being proposed capable of providing the necessary reduction? Is the timeline appropriate? So will the mitigation be effective ahead of the impact taking place? And will the mitigation be secured for the duration of impact, which, if we're talking about residential development, would be in perpetuity? And then finally, if you can't conclude that there'd be that an adverse effect on integrity can be excluded, then planning permission should not be granted. So I've included the derogation stage in this for completeness. So where an appropriate assessment is unable to conclude that an adverse effect can be avoided, then either new or additional measures should be brought for, should be sought, and the appropriate assessment reconsidered with that new information, or assuming that this is the chosen path, you could proceed to apply the derogations. Now, before I go any further on this, I would highlight that it's likely to be very, very challenging for any residential permission to meet the derogations test, which is that there are no satisfactory alternatives and that there are imperative reasons of overriding public interest. The reason I say it's likely to be challenging is that there's always the point that there are likely to be alternatives, i.e. that development could come forward outside of the nutrient neutrality catchment. I recognise that doesn't mean that for some authorities would mean that it would be outside of the local planning authority area, but as far as the regulations would consider it, that would potentially be an alternative. It's also quite challenging to make the imperative reasons of overriding public interest argument. These derogations really are more for large schemes that cannot possibly be located somewhere else. So an example I've used before would be something like a coastal defence or flood defence scheme, which has to be in a particular place in order to defend the areas that require defence from that flooding. But what the derogations do enable is compensatory measures to be provided in the absence of sufficient or suitable mitigation measures. Again, highlight that the compensation still needs to be provided. So there's no shortcut here. In fact, compensation is likely to be more onerous than mitigation. So again, I would suggest that you're far better off looking for mitigation at stage 2 rather than thinking about going down this route. And the challenges, as I've already highlighted, are that there are likely to be alternatives. It's likely to be challenging to demonstrate that housing delivery satisfies the imperative reasons of overriding public interest test. And obviously that the compensation is still a requirement, and may well is likely to require that the compensation is of European site quality, so is more onerous than delivering mitigation. So moving forward to looking at the nutrient budget calculators, the next few slides look at each stage of the nutrient budget calculator in turn. And we've populated an example into the calculator for you. So working down from the top, I'll just discuss what each input is for. So the reason that there's a date of first occupancy in there is that some wastewater treatment works have got upgrades coming during the current price review period, so during PR19, where that's the case, and it isn't in this particular example, the calculator will provide you with the pre-2025 data, so the pre-upgrade concentration figure and the post-upgrade concentration figure. So the reason it requires a date of first occupancy is to know whether it needs to apply the pre-upgrade value as well as the post-upgrade value. So if the date of first occupancy was in 2025, it would just display the upgraded wastewater treatment works value rather than the pre-upgrade one as well. The next one is the occupancy rate. Natural England have provided some guidance in the calculator guidance document around occupancy rates. So it's for the local planning authority to determine what the most appropriate rate is, be that a nationally derived rate, such as the ONS 2.4, which is what the calculator defaults to, but that can be changed to a locally derived figure if there's sufficient evidence to justify using that. The one thing I would say is that Natural England's advice would be that whichever figure you go for, you use that consistently for every development rather than potentially chopping and changing between multiple figures, which is likely to increase the risk of legal challenge. Next one is water usage. So what we've advised is that whatever water usage is secured by the planning permission, be that the higher building reg standard or some other local policy-based water use, that 10 litres per day is 10 litres per person per day is added to that figure. That's to ensure that the data being used is precautionary, reflecting on the fact that there's no way of controlling what fixtures and fittings are subsequently put into that development once it's been sold, and once it's over the lifetime of that development, less efficient fixtures and fittings could be put in place, which would obviously increase the water consumption. The next one is the number of dwellings, which is obviously straightforward. Then there's a drop-down choice of options for the wastewater treatment works. So all the wastewater treatment works within the catchment will be included in there, and the calculator is pre-populated with all of the permit data for those wastewater treatment works. So selecting the relevant wastewater treatment works will then generate the milligrams of total nitrogen or total phosphorus per litre for that works. And what that enables the calculator to do at stage one is, using the additional population and the water use per person per day, it enables a water use figure and then a total nutrient load from that wastewater to be provided, which is that figure at the bottom of 499.66 in this particular example. So stage two is looking at the existing land use of the development site. So the land use prior to the proposal coming forward. So this is this particular example is assuming this is a greenfield site, and this provides the value for effectively the amount of nutrients that are currently lost that would stop being lost due to the change in land use. So again, going from top down, the first step is to identify what catchment or subcatchment the proposed development site is within, and the information for that, as well as whether or not it's in an NVZ, can be found following the links to a searchable website that's contained within the calculator guidance document. The next one is to define the soil drainage type and the average rainfall band that the development site sit within. The reason these are included is that how the soil type and the rainfall have a significant influence in the rate of nutrient loss from the land. So that's why these bits of information are required in the calculator. And again, there are specific links provided in the calculator guidance document that take you to a website that will automatically direct to a local area within the catchment to enable these figures to be identified. And again, all of these are drop downs, so there's a choice of options to pick from. And then the final one is whether or not it's in a nitrate vulnerable zone, which again, a link is provided to a website that helps identify whether or not that's the case. Then going down to the next section of the calculator, the existing land use type again is selected from a drop down. So all of the land use types that exist within the catchment are included in that drop down. So you select the current farming practice or crop that's on that piece of land, put in how many hectares the development site area is, and that will generate a current nutrient export value for that site prior to development. So again, in this case, that comes out at 306.96. So the third stage is the future land use or the proposed land use. So the post-development land use, and this is this automatically has taken the data from stage 2 around all of the, which part of the subcatchment it's in, which rainfall band, etc. So you don't have to put all that in again. So all that's needed for stage 3 is to again select from a list of drop-down options as to what the post-development land use will be. So in this example, that 11 hectare site is made up of predominantly residential urban land with also some open urban land included within the development proposal. And again, the calculator can then automatically generate the nutrient export values for those different proposed land use types to give the total at the bottom of what the nutrient export post-development would be from that site, which is 125.56 in this example. Stage 4 then just gives you that total nutrient budget for the development proposal. What that's doing is taking the figure from stage 1 and the figure from stage 3, because they're the two new outputs of nutrients as a result of the development, and subtracting stage 2, because that previous nutrient loss from the agricultural land use will cease. So that's then subtracted from the nutrients that will be coming from the new development proposal, which in this case gives a number of 381.91. What I would highlight about stage 4, because I've had a few questions on this, is that doing stage 1 plus stage 3 minus stage 2, if you took the raw figures in the previous stages, doesn't equal 381.91, which has caused some confusion. But the reason is that, as set out in the methodology and the guidance document, a precautionary buffer is applied to the annual nutrient budget. So the numbers from stages 1 to 3 have 20% added to them as the precautionary buffer to generate this number. So that's why it doesn't add up exactly to stages 1, 2, 3. So just wanted to highlight that just for clarity. And that 381.91 figure is the amount of, in this case, nitrogen that would need to be mitigated for on an annual basis to make this development nutrient neutral. For completeness, I thought it'd be helpful to show what the Lookup tab contains on the nutrient budget calculator. So this is effectively the table that the calculator is drawing the information for the wastewater treatment works from, and it's a useful tool for you to be aware that it's there, because it does set out all of the wastewater treatment works within the relevant catchment, so it's a useful list to be aware of for reference. And what the table includes is the permit values for both phosphorus and nitrogen for those wastewater treatment works. You'll see that there's two sets of columns. So the first two, unfortunately, I've picked a bad example to screenshot because none of the works shown in this screenshot have got improvements during PR19. So none of them are expecting to be improved by 2025. But what you would see is in the second pair of columns, the post 2025 columns, those would be the values of the new permits that are going to be put in place by 2025. So that gives you the current values and the known future values where there are different ones. I'd also highlight that you'll see a lot of 8s and 27s in that list. So where wastewater treatment works don't have a specific permit, the calculator has been pre-populated with 8 milligrams per litre for phosphorus and 27 milligrams per litre for nitrogen. Those are deliberately very precautionary figures. So we looked at various data for wastewater treatment works that have no permit, and we selected the highest values. So 8 was the highest value for phosphorus, 27 was the highest value for nitrogen. So those have been put in as default values for wastewater treatment works with no specific permits. What I would highlight, and this is covered in the methodology, but what I would highlight is that there is definitely a benefit to discussing with the local water undertaker, water company, to get data on those works that don't have permits, because in a significant number of cases, it is likely that the actual value will be lower than 8 or 27. And it's perfectly reasonable to use a value derived from the water company. The only thing I would say is that there needs to be, you need to factor in likely growth into that. So for example, if the water company came back and said, oh, well, this particular waterworks is actually discharging at 4 milligrams per litre, if you know that there's a modest amount of growth anticipated during the plan period for that works, it would probably be precautionary to up that from, say, 4 to 5 for the use in your calculation, just so that, again, to minimise the risk of any challenge. But yeah, just to highlight that those discussions are well worth having, because they will, in all likelihood, reduce those figures. So before I finish, some of you will have seen this slide before. I've used it in a previous presentation to one of these PAS workshops, but I thought it was, oh no, I'm sorry, I'm ahead of myself. I'm talking about the next slide. Apologies. Yeah, I thought it'd be helpful to talk about the differences between the new approach that Natural England have issued and some of the previous approaches that were in place for some catchments in England. So firstly, the water usage figures. So as I've already set out, we talk about, or we advise that the figure that is secured by the permission has 10 litres added to it. And as I've previously said, this is there to account for changes to less efficient fittings during the lifetime of the development, just to ensure that the calculation is precautionary. Some of the previous methodologies didn't include that additional 10 litres in the approach. Then all the agricultural land use figures, so the figures used for stage 2, these are all based on Farm Scoper version 5, which is the latest release of Farm Scoper. So the majority of previous calculators methodologies would have been using older versions of Farm Scoper. The other difference is that it includes that location specific information that we talked about when we were looking at the calculators which is the inclusion of the rainfall band that the site sits within, and also the soil drainage. Previous approaches have tended to use catchment averages. So the value for a dairy farm would be the same across the entire catchment. The evidence that Natural England looked at and the information that Natural England reviewed prior to developing this latest approach was that rainfall and soil drainage can have as significant as an impact as significant as the farm type on the actual nutrient export. So we decided it was important that farm type, rainfall and soil drainage were all considerations at a site level to ensure that accurate information was coming out of the calculator. What this means for areas that may be moving from one approach to another is that you will see instances where for some development, if you ran it through an old calculator and the new calculator, some will go up and some will come down in terms of mitigation requirement. That simply reflects the fact that previously an average figure was used. So for some locations within the catchment, the new calculator will lead to a reduced mitigation requirement, and for other locations within the catchment, it will lead to an increased requirement for mitigation. As I say, that's obviously what happens when you go from having an average to using site-specific data. The other thing that's changed is around the figures used for urban runoff. In Natural England's previous approach, pet waste, the factoring of pet waste was within the green space rate. We've now excluded it from the green space rate and added it into the urban rate. Again, the view on this was that people have pets regardless of whether there's green space included as part of the development, and therefore it made more sense to include it within the urban rate rather than in the green space rate. And then finally, as I've already touched on the previous slide, wastewater treatment works without a permit now have a default figure. So our previous advice didn't have a figure at all for wastewater treatment works without permits. It was just left to the local planning authority to work with the water company to come up with a figure for such works. Whereas what we've done now is put in a default figure. But again, I would highlight that that doesn't mean that bespoke figures can't still be agreed with the water company. We just thought it was helpful to at least have a default figure so that where it was not possible to get any data from the water company, there was at least a figure that could be used for the calculation rather than just sort of trying to work out what to do in that scenario. And what I would highlight is that under the previous approach, where a bespoke figure couldn't be agreed with the water company, the figures that Natural England were generally advising were in line with the figures that are now default within the calculator. So it's more a change of presentation really than a change of approach. So yes, apologies. This is the slide I thought I was talking over previously when I said that a number of you may see this and it might be familiar because I have used it in a previous presentation, but thought it was useful just to revisit around mitigation. So as I'm sure you're all familiar by now, the nutrient neutrality approach is based on the principle of reducing existing sources of nutrient pollution to mitigate, to offset the additional nutrients generated by new development. So there's a number of principles that stem from that. The mitigation needs to be in place before the new development causes its effect. So mitigation needs to be in place and operating prior to occupation for residential. Needs to be in place for the duration of the impact. So again, for housing, that would be in perpetuity. And it needs to be suitably located to remove the effect of the new development. What this basically means is you can't allow the impact of the development to impact the site, the protected site, prior to the benefit of the mitigation having its effect at the designated site. So what that means in practical terms is it needs to be in the same catchment as the development. So if you've got particularly big catchments, the Solent's quite a good example where you've got a number of rivers coming into the coastal system that's protected. So you would need to make sure that your mitigation was within the same river catchment as the development. So you can't have the development in one sub-catchment and the mitigation in a different sub-catchment, because that would allow an impact to occur at one part of the site and a benefit to occur at a different part of the site. And also the mitigation needs to be upstream of the European site and or upstream of the development. So if the habitat site, the European site, is at the bottom of the catchment, if it's the harbour or an estuary, then your mitigation can be anywhere upstream of that, regardless of whether that's upstream or downstream of the development. But if you're talking about a designated river where the entire river system is designated, then the mitigation would need to be upstream of the development. Otherwise, a small part of the site, however, whatever length of river there was between the development and the downstream mitigation, that section of the site would still be having an impact. And the reason we go to such length to highlight this is that if you don't have your mitigation in a suitable location, i.e. if you had a sack river and the mitigation was downstream of the development, you're effectively allowing an impact to occur and then compensating for it afterwards, which moves us into that whole derogations, imperative reasons of overriding public interest space, which we really don't want to, I'm sure none of us particularly want to be in. So that's why location of mitigation is so important. Again, helpful to highlight that mitigation can be provided by various different actors. It doesn't have to be provided by the local planning authority. It can be provided on a case-by-case basis by the project proposer, the developer. It can be provided strategically by the local planning authority, or it could be provided by third parties such as wildlife trusts or any other landowner that is looking to take on mitigation as potentially as a diversification for their land holding. And then finally, just to touch on some examples of mitigation, obviously there are a significant range of mitigation options. So I've just tried to sort of group some together here. So you've got on-site measures such as sustainable urban drainage schemes. They can be a mitigation measure, but more often than not, I would tend to consider them as a reduction measure. So by putting SUDs on site, the figure at stage 3 can be reduced, because the developer can demonstrate that a lot of the surface water isn't leaving the site. It's being captured through SUDs. It's been potentially then treated through SUDs prior to discharging from the site, and that treatment through the SUDS train can be taken into account when assessing the amount of mitigation that's required. It can also be retrofitted to existing developments as a mitigation measure. So you can theoretically add SUDs to the development that's already been built out, and that the benefit and the nutrient reduction from the SUDS trains added to those existing developments can be used as a mitigation measure to offset the additional nutrients as a result resulting from the new development. Then we've got agricultural land use change. This is probably the most widely used mitigation measure that's come forward thus far. I would highlight that it's much more effective, or it's much more cost effective for nitrogen than it is for phosphorus, because phosphorus tends to bind to soil far more readily than nitrogen does. So agricultural land use change is not such an efficient mitigation measure for phosphorus as it is for nitrogen, but essentially it's taking land out of intensive agriculture and converting it to woodland. The reason we advocate converting it to woodland is it makes monitoring the presence of the mitigation far easier going forward, because it's relatively straightforward to ascertain whether woodland is still there. Whereas if you've just fallowed the agricultural land, it's challenging to be able to demonstrate that no nutrients have been added to that land after it has changed use into a mitigation site. Then you've got wetlands. Broadly speaking, they fall into two categories. We define them in two categories: treatment wetlands, which are taking effluent discharge from wastewater treatment works or packaged treatment plants and running that through a wetland to do further treatment to reduce the nutrients. And then the other type of wetland are the interceptor wetlands, which, for example, could be treating agricultural runoff before it reaches the watercourse, again, to remove nutrients. And finally, I've given the example of replacement of inefficient PTPs, package treatment plants, septic tanks, with new efficient package treatment plants. So this is where there are existing developments that have got older, less efficient package treatment plants, and the project proposer for the new development could offer to replace those with more efficient, more modern installations. And the benefit of that in terms of the reduced nutrients entering the system would then accrue as mitigation to the developer. On a couple of those, so particularly on the wetlands, Natural England are working with the Rivers Trust and the Constructed Wetlands Association to produce some internal guidance for Natural England, but also some external best practice guidance for the industry, for those that design and construct wetlands, to give them further advice and guidance around what the key considerations are for wetland proposals. The intent with that is that wetland proposals will be able to come forward with the information that both local planning authorities and Natural England need to be able to make an assessment of how much nutrient those wetlands will remove. So the idea behind having that sort of twin track internal external guidance is that both the way Natural England assess wetlands and the way the industry design wetlands will accord with each other, and will make things much more straightforward when it comes to undertaking that assessment. And then, as a general point, to highlight that we're also working on a document that sets out which mitigation measures are likely to be effective in different scenarios, and that piece of work is ongoing at the moment. I just saw a question pop up about timelines for that. We're just in the final stages of the wetlands guidance, so I anticipate that being completed within the next month or thereabouts. The wider piece on effectiveness of a whole wide range of mitigation measures is slightly behind that. We hope to have that completed within the next 2 months. And that second piece we will be sharing with local planning authorities, and we need to see what to do with the wetlands one as to whether to share it or not. It'll depend on what the external guidance side of that looks like. If the external wetlands guidance is effectively as comprehensive as the internal stuff that was produced for Natural England, then that will fulfill that role. But if we feel that there's a benefit to sharing our internal guidance, I'm sure we could look to do that. So I shall hand back to Rachel to coordinate the questions.
Great, thank you, Simon. Thank you so much. That was really interesting. That was good to go through all that detail. A few questions have come in, so we will try and run through some of these, and I've tried to group them as best as I can to make it easier. Thank you for updating on the new guidance that's coming through for mitigation and wetlands. That's going to be really interesting. A couple of other questions just on updating the guidance. One is, a couple of the calculators are missing some of the wastewater treatment works that are in the kind of lookup table at the back. Is there an opportunity for the calculators to be updated at this stage to include that further data? And then looking longer term, how will the calculators be updated when there's perhaps changes to agricultural baseline or wastewater treatment works improvements?
Yeah, so on that first one, yes, we would greatly appreciate it if any emissions that are identified in the calculators can be flagged up to us. We thought everything was included, but yeah, it's always possible, and clearly is the case in some cases, that things have got missed. So yeah, we can absolutely get things added in if they have been missed. So if you could flag that, if they could be flagged to me, that would be really helpful. On the second point around updating, very conscious of the feedback we have received over the way the advice landed in March, and the challenges that presented for probably everyone on this call. Natural England are currently working up with our legal team, etc. Basically, I don't actually know what to call it because we haven't given it a name yet, but effectively a statement or a position on how we will go about making any future updates to the approach and to the calculator, so that we can share that with local planning authorities and make sure everyone understands under what circumstances Natural England would change the approach. The proposal is at the moment is that unless something unforeseen or something we can't plan for comes forward, such as a judicial review or something like that that requires a change outside of a timetable, that our plan would be to review and update the calculators in line with the water industry asset management plans price review process, because we'll need to reflect permit changes on a 5-yearly process. So that's our proposal at the moment, is that we would review the approach in line with that, so that we can take account of the new permit values for wastewater treatment works, build those into the calculators, and also take the opportunity to see whether any other information requires updating, such as if Farm Scoper version 6 may have come out during that period as well. But we will definitely ensure that we communicate with local planning authorities to set out to them what the changes we're proposing are and when we're proposing to do it, in advance of making those changes.
Great, thank you, Simon. A couple of questions have come in linked to occupancy and water use. One question is to do with, obviously, packaged treatment plants and septic tanks. They're often sized on population equivalent systems. So three houses could be equivalent to a much greater occupancy than the 2.4 that's used in the calculator. And then equally, the calculator uses water use, which is linked to the 120 litres a day. Could you just run through the reasoning why Natural England have used kind of the average occupancy for all cases, and whether there's any evidence of water usage slippage over time with efficiency measures that are put into new houses?
Yeah, so the ONS 2.4 figure is the figure that we've pre-populated the calculator with, but I would highlight that that is an editable figure. So local planning authorities can use whichever figure they consider population-wise to be or occupancy-wise to be the most appropriate for their area. We've provided fairly lengthy guidance on this point in the guidance that comes along with the calculator, which effectively sets out that there are potentially, in our view, 3 options open to local planning authorities. One is to use the national average figure, one is to use a local average figure, or the other would be to use a per bedroom figure. My personal view, and it's my personal view, it's not Natural England's formal view, is that using a per bedroom figure will make things more complicated, because we advise that if you're using it that you use the same approach consistently. So if you're using a per bedroom figure, it should be used consistently for all applications. Going down that route particularly potentially then opens up the need to consider householder applications, because if you're adding a bedroom, then you could make the argument that that's going to change the occupancy of the dwelling. Whereas if you use an average, be that national or local, it is likely to get around those sorts of detailed issues on a case-by-case basis. But yeah, so that's where Natural England are coming from. We do recommend that an assessment is done at a local authority level to decide which is the most appropriate figure for you to use. So obviously, if your local average occupancy is significantly different to 2.4, and you've got the data available for that local occupancy, then that's likely to be a more robust figure to use. Whereas if it's broadly similar with the national figure, then Natural England don't see any issue with using that national figure. I will caveat all of this with the fact that occupancy rate was one of the points considered by the judicial review, Wyatt versus Fareham, which has obviously recently been at the Court of Appeal, and we haven't had a judgment on that yet. So it is possible that our advice around occupancy rate may change as a result of what the Court of Appeal decides. But Natural England feels that the advice we've provided is robust, which obviously is why we provided it, even knowing that that appeal was taking place.
Great, thank you, Simon. And in terms of the water efficiency, is that changes in water efficiency measures over the lifetime of the development? Is there lots of evidence that's coming through on that element that you're aware of?
There's certainly evidence that water use can often be above the water use figure that's defined under the building regs, which is why we just, sorry. Apologies for that, which is why we felt it was necessary to add the 10 litres per day. I think that is a relatively conservative addition, looking at some of the figures, but when you look at new development, the water use figures do seem to be significantly lower than if you look at development overall. So yeah, we are confident that adding 10 litres ensures it's sufficiently precautionary, but we would, we do feel that there is the need for that, because the water use figures seem to suggest that new developments are pretty close to what's required already. So it wouldn't take much in the way of revisions to the fixtures and fittings within dwellings over time to slip above that.
Okay, thank you. And another question's come in on sustainable urban drainage systems. And obviously you've mentioned that that's part of on-site design measures that developers can do it, can progress. We've had one question that came in from an earlier workshop about whether the calculators could include an entry for SUDs in due course, and if there's further guidance coming forward on that. And also another question as to other on-site reduction measures that could be adopted by developers as well, please.
Yes, theoretically, it would be possible to get the calculators amended to enable a figure to be added in for SUDs. That would be something that could be done in future. But yeah, at the moment, it would be you'd need to do it at the end of the calculation, essentially. So you'd then need to subtract whatever the figure for the reduction in nutrient loss from the site would be as a result of the SUDs train. And I didn't mention, Rachel, the work that you've been doing at Wiltshire around the effectiveness of different SUDs measures. So that is another piece of work that Natural England has contributed to, but it's very much been led by Wiltshire Council, which is designed to provide further information on the effectiveness of different SUDS measures. So that would be another useful tool to help inform what those reductions are likely to be as a result of incorporating SUDS.
And are there any other on-site measures coming forward that you're aware of that developers can do, I suppose, apart from additional open space? Is there anything that's coming through that's helping that you're aware of?
Yeah, as you say, that the obvious one is increasing the amount of open space within a development, but obviously recognising the constraints to that. Beyond that, there is some work going on, or Natural England are doing some work around on-site measures for drainage fields from PTPs and septic tanks, around how tree planting, use of fruit trees to draw up phosphorus from those sorts of installations can remove a significant amount of the nutrient that would otherwise make it eventually to the designated site. So there is some emerging work on that, but it is at very early stages at the moment. But for the majority of developments that are connecting to mains at the moment, the only sufficiently certain thing that I'm aware of is SUDS interventions.
And a couple of questions are coming in about calculating the benefits of mitigation in terms of the nutrient benefits. So, for example, the benefits from wetlands. Will the new guidance include easy ways to calculate nutrient benefits? And are you aware of how local authorities have been using measures, whether they've been using a charge on developers, and whether there's a standard charge that's coming through from local planning authorities as yet?
So on the wetland guidance, or the mitigation guidance generally, but particularly the wetland one, the guidance is basically designed or sets out what wetland proposals need to provide to local planning authorities to enable an assessment to be made, and that does include the steps through which those proposals should define the amount of nutrient reduction from that proposal. So we would expect that a wetland proposal would come forward and be providing a number to say this is how much nitrogen or phosphorus per annum this wetland will remove, which obviously then makes it comparatively straightforward to work out how much mitigation that is providing.
Okay, thank you. And just on the last question, because I'm conscious we'll go to a break in 2 minutes. In terms of standard charges coming through from councils, is there anything appearing from those catchments that are already affected if there's a standard charge on developers for a Section 106 contribution, or is it still early days?
I mean, it is early days, but certainly those authorities, there are a number of authorities, particularly in Solent, where they have brought forward their own LPA-led schemes, and certainly for those, they have been able to then define a credit price. So any development relying on those strategic mitigation schemes will know what the cost per kilogram of nutrient mitigation is. But they range, so that there are a number of different schemes in a number of different authorities, and they do have different prices. So there is no defined nutrient credit value at this point. There will be on a local area by local area basis, but no, I wouldn't say that there's an obvious sort of, oh, they cost £5,000 a credit. It does vary.
Brilliant. Well, Simon, thank you so much for running through those questions. There's a few more that have come in the chat that we'll pick up